Okay, in the lab we did today, we were looking at air pressure and how gases react when under pressure. Some of the first things that we looked at was the question here, what is air? And we're going to say that air are the gases that make up Earth's atmosphere. The main two gases in Earth's atmosphere are nitrogen and oxygen. Nitrogen makes up about 78% of Earth's atmosphere, and oxygen makes up about 21% of Earth's atmosphere. There are a lot of other variable gases and other gases in smaller amounts that fill in that other 1%, but we'll go over them more later. Now, in the lab that we looked at in class, we were looking at gas in a syringe, and we're wondering, when we start to put it under pressure, where is the air going? So we have the question there, and we have the air is being pushed into a smaller space. It's the same amount of air, it's just compressed in a smaller space. So when we look at the video of this, you can see we have the syringe here, and as the syringe is being compressed, we can see that the air isn't escaping in any way, it's just being compressed, and it actually is pushing back out. So what is happening to the air inside the syringe? Okay, it's being pushed into a smaller space. When it's compressed, the air pressure builds up. The plunger, when it's let go, pushes back out, and does that until the pressure inside and outside are the same. If we take a look at the diagram here, we can see the air molecules moving around inside, and we can see the light blue air molecules outside. So when we compress the air molecules inside, they're staying inside the syringe, they're still trapped in there. When we let go of that, because there's higher pressure inside, it's going to push back on the air outside. Okay. One of the next things we did with the syringes is we started to look at what happens to the syringes if we take all of the air out of the inside, and then we try to essentially create a vacuum inside the syringe. And we see that when we do that, it gets sucked back in, and the reason it gets sucked back in is with a very little air inside, the pressure of the air in the room is greater, and it causes the plunger to compress or collapse back in. And it does that again until, very importantly here, it says the pressures are equal. And that's one of the main things to understand, that these processes are going to take place until the pressures are the same, or they've reached what we call equilibrium. And we have the video of that happening here in class. So right there we have it clamped off. There's essentially very little to no air inside. So it has a very, very low air pressure. And the air pressure in the room causes that to suck back down, or forces that to collapse in on itself. One of the next things that we added to these syringes were some pieces of blue foam. And we wanted to know what the air did to the foam as we started to change the air pressure inside the tubes. So the air molecules get forced into a smaller space, and they begin to compress the foam into a smaller size. Essentially, we're looking at the air molecules beating on the pieces of foam. So when we add pieces of foam inside here, we're going to see these same air molecules, as they get pushed into a smaller space, they're going to bounce around more often, and they're going to start to bounce off of the foam a lot more and cause it to shrivel or shrink. So we have a video of that in class. You can see the blue foam here, and as we compress it, we can see that they start to shrivel up. It's a little easier to see from this angle here, and they start to shrink and shrivel just on the air being compressed around them. Okay. One of the next things we did was we tied two syringes together in class. So when we tie the two syringes together, we can demonstrate how the air pressure can build up in the two different sections. We can see by squeezing one section as the air pressure is moved from one side to the other, it does have an effect on the other side. As we create a little bit of a vacuum on one side, even without moving it, it will get pulled by the other side. And then we looked at a buildup of pressure causing it to pop off. So when we had that happen, we looked at a little bit of a buildup in pressure. And with that buildup in pressure, at some point the plunger is no longer strong enough to stay together, and it will essentially break or pop off. So when we go back to this video, we could see in this one with the two syringes tied together, we have as much air as possible in both syringes, and as we go through, we could see the buildup in pressure, and at some point eventually the buildup in pressure becomes great enough that we get the plunger to break. It overcomes the friction holding the plunger in place, and the air pressure pushes the plunger out or causes it to pop off. So those are the things that we looked at in class with our lab on gas in a syringe. And if you have any questions, feel free to stop by in class and ask.